So, in the last module related to the multi-threaded programming in Java, we have discussed about the basic concept about multi-threading, and then how the thread can be created in Java program, and then how the different threads can be executed in parallel. And in the last discussion, we have used the class thread to create our thread. Now, in this discussion, we will discuss about how the thread can be created using the runnable interface. The procedure is very similar to the thread class creation, only few minor differences there. Now, let us first start with how we can create a thread using runnable interface. As you know, if we want to create our thread using class thread, so we have to create a thread class which is basically extending the class thread. On the other hand, the same procedure, but here we have to create a thread class which implements runnable. Now, implements runnable means in the runnable interface the method run method is there, which is the public and abstract method. This method needs to be created. So, it is basically implementation of this run thread is similar to the implementation of run method that is there in the thread class there. So, in that case the thread class run method they are in okay, if you have to extend thread class is overriding, but here the run method is to be implemented. Once this class thread class is created by runnable interface, then we can create a thread objects. For example, here T is the thread objects, and when you create the thread objects, you see we use the thread class and pass this as a parameter. So, the my thread that you have created in new my2 all object it needs to be passed. So, this is the only difference that you have to do. In other cases, if you use the thread class, so thread to new thread, no argument to be passed. So, the only the default constructor will take place, but here in this okay, if you use a runnable implement the thread class using runnable interface, then that object needs to be passed here. That is the only difference, otherwise everything is same basically. So, here T dot start is basically to start the execution of this thread. Now, it is basically same again that this is the run method that we have to define, as it is we have defined there in the okay, creating place using extension of the thread class, and then okay, T start. So, both the things are here again. Now, let us again repeat the same procedure that we have discussed about in okay, in our last module example we have considered about 3 threads, thread A, thread B, thread C, which basically print negative number, even number and odd number. The same concept here also we are we will just implement it, but using runnable interface. So, that we can understand that how the two things are work for us. So, here exactly let us see this is the thread X, I have given the name thread X in this case, implements runnable. So, this is the similar the run code that we have used earlier, and then thread Y same as thread B that we have discussed there, but it implements runnable run method here. So, thread X, thread Y are declared, and then it will implement the thread Z. So, this is the thread Z. So, 3 thread X, thread Y and thread Z are implemented. So, created we can say 3 thread class are created by implementing runnable interface, and this is the main method as we see here, this is the main class, and here you can see we create X, Y and X and Y are the thread object of this thread X class, and then thread is basically created T1 by passing this X, because if you use a runnable interface that object needs to be passed as a constructor to call the thread class. Actually, this is a constructor that is defined in the thread class. So, this way you can see T1, T2 and T3, as you can see in this case again we can call in on here actually 2 step process, but it is a single step process. That means, we can create the thread, directly call these things by passing this also, it is okay, equally applicable here. So, what you can see here T1, T2 and T3, 3 threads objects are created, and once these 3 thread objects are created, they are ready for execution, and these are the basically to start the thread we use T1 dot start, T2 dot start, T3 dot start, and then thread will be run in parallel. So, this is the multi-threading using runnable interface as we have learned it here. So, we can see basically same thing, implements versus extends, and then just how to create the thread object, otherwise for the run and everything same in the both concepts. So, the two ways of running multi-threading program using extends and runnable interface. So, there is no, I mean, as such a rule that okay, this works this way, this works. So, basically the different syntax we can say, the different procedure how the different thread can executes. Now, so we have learned about how a thread can be created, although it is a simple example that we have considered, but this is the idea about, and then it can be extended to any type of complex there. Any number of threads can be executed, any number of threads can be then started to execute. Now, there are many more things are there, particularly a thread can be in a different states. So, now we will discuss about what are the different states that a thread may have, and this is very important because whenever you have to control a very complex program, you should know the different states of a thread that it may have, and then how we can communicate the one thread to another. So, basically the inter-process communication. Now, so far a thread is concerned, it has different states, like thread can be in a new states. So, this means that thread is just created and it is yet to start its execution. So, it is a new runnable. So, thread is basically being execution, that means it is okay, about to run, and running, this is basically active, the thread is in the execution, and blocked, somehow thread needs something or thread has been stopped or it is sleeping. So, that means thread is in a waiting state, it is called the blocked state, and then finally, a thread can be in a dead state, that means when it finished its execution. So, these are the 5 different states that a thread can be in this there, and there are different methods by which a thread can change its state, like a new, start, yield, sleep, wait and notify, and other some external events also there, scheduler, IO and returning from run and resume, all these things are there. Now, let us have a detailed discussion, detailed account of all these methods which basically to control the states of a threads are there. Now, this is the state transition diagram for a thread that it may have. As we have checked that a thread can be in a new state. So, whenever the created and then this thread can be in a new state, this means thread is not yet started its execution, but ready to start its execution. When the start method is called, then this thread is basically a runnable, but is runnable basically gives to the scheduler. It is basically the Java runtime manager, it basically all the threads are now started it, but is about to execute or run it. When the scheduler can call it, is basically yield and then time slice is allowed to each thread, maybe in a time sharing manner, that the okay, it will share the different resources, CPU, all these things on. So, this is totally is a paradigm of Java runtime manager, which we should not bother about anything, but it is basically working like this one. So, whenever it is there, so it is a running. So, there again once the thread is running, that thread can be stopped or it can be resumed or it can be terminated or suspend. So, it is basically terminated. So, once the terminated, the thread will go to the dead state. Otherwise, if the thread is waiting for any resources in that it requires, maybe thread is waiting for some other disk or memory that it is waiting. So, these are the running to, it can go to the waiting state. So, blocked. Now, running to waiting state, the different methods it is there, IO request, sleep, wait, join, suspend, these are the methods which can change the state from running to blocked state. From the blocked state, it can again runnable, the different methods which are responsible to move a state from blocked state to runnable states are here. So, these are the way that the thread can change from new to dead state and the different processes are there. So, this is basically state transition diagram says that how the state of a thread can change and what are the communicating methods are there to control the execution of a threads, and then thread can be in a different state. So, these are the different methods that we have learned about. Start method we have already used it, and then suspend method. Suspend method is not exactly the stopping. Stop method means the thread will be dead, but suspend means it will temporarily halt the execution, and then if a thread is suspended by the calling suspend method, it can be again revoked using resume method. Now, resume method is basically when the thread is in a waiting state or in a block state, it can be turned into runnable state, so that scheduler can take all the threads from the runnable state to assign to the CPU for execution. And then sleep method is basically by explicitly maintaining that thread should stop it here, wait for some seconds, maybe n milliseconds, like what the argument is n there. So, sleep means the thread will not do anything, only the sleep for some times. And yield method is basically switch the text from the context of a thread from the current thread to the next available running thread that is there, runnable thread. So, it is basically usually this yield method used by the scheduler to invoke a thread which are waiting, ready for execution, that is there in the runnable state. Now, let us see how the thread scheduling can be done, and thread scheduling can be done. There are actually scheduler. The scheduler is basically responsible for scheduling a threads. That means, scheduling a thread means it basically assign threads to Java runtime manager, and is basically determines that which threads which are there in a runnable state can be assigned to the system for execution. Now, again in the Java system, we can assign the priority, low priority, mean priority, high priority, max priority, like. So, according to the priority, scheduler will call revoke a method, a thread from the runnable state to this one. And there are some threads we call the demo thread. So, demo threads are basically running all the time in the system, and then scheduler can interact with them, so that they can be executed, and then they can be control their execution, and the thread can be in any other states there. So, the demo thread is basically for the general service. Whenever suppose you just insert one disk, so automatically detect that disk is there. Whenever some interrupts are coming, the demo thread will take. These are the few examples are there. Now, the program can be terminated whenever all threads are finished its execution. If there is some thread is yet to be executed, the program cannot be terminated, and then we have to do for the forced termination by pressing power button or like this one. Anyway, so whenever the scheduling of a thread is concerned, again in the system there are two type of scheduling called the preemptive scheduling and non-preemptive. Non-preemptive means once the thread is in execution, if it is a non-preemptive scheduling it is followed, then this thread cannot be interrupted until it finish, it will start its execution. So, no way it cannot be interrupted, whereas the preemptive scheduling means thread is in execution, it can be preempted, maybe either can be change its state from running to waiting state or sleep or whatever it is there. So, it is basically the policy how you want to control the threads in your execution. So, this is an idea about the preemptive scheduling, that it basically. So, whenever the thread is in running condition, it will either terminates or it will go wait or ready until it finishes its execution. So, this is the idea about the non-preemptive scheduling. That means, it will no interruption is allowed in case of non-preemptive scheduling is there. On the other hand, in case of preemptive scheduling, as we see, as we see, the preemptive scheduling is basically if there is an interruption occur. So, it basically not wait, it will from the run state to go to the ready state. So, this way preemptive is occur. Anyway, so this is a matter of policy that you can implement in your system, and this is the concept of idea about managing the systems whenever you have to implement it. So, preemptive, non-preemptive are the core concept of how you want to control your process in execution, or you can say the thread in execution. Now, let us have an example how the different methods are there which can be implied to a thread whenever it is in execution. This is again simple method that we can understand about it, and it illustrates how the sleep method will work for you. So, here is an example. We can see we create a thread class. The name of the thread class is thread example, which is basically created using thread class. So, extends thread. Now, I can tell you using implement runnable also you can do it anyway. So, here is the run method. As you see how you can code the run method, then this one it is basically is a loop, for loop, and here you see sleep. We use the sleep method for this. That means, whenever it is executed, this for I equals to 0, it will just call the sleep method and it will sleep for 5000 milliseconds. So, 5 seconds like, and we put this code into the this one, because here there may be an exception occurs that thread is no more there, and then we want to call this thread using sleep method. So, this is why it is better to put under try catch. So, it is basically interrupted exception. If it is occurred, then it can caught it and then handle from the premature termination of the program itself or the robust program. This is basically exception handling concept, it is followed there. Now, as we see, so this is the run method. This run method is just run the thread, and here the idea is that thread will for each loop whenever it run. So, first 5 seconds it will sleep, then again 5 seconds it will sleep, and then another 5 seconds it will be sleep like this one. So, it is the idea about sleep there, and if you print one system statement system.out.println before here and after here, that before sleeping first and then after sleeping first, then you can see that. So, the threads are executed in parallel wherever it is sleeping intermittent way. So, here is basically the idea about, here we can see we have created two thread example object and then start there. So, that means we run two threads parallelly, and if we run these threads parallelly with their print statement here, in our demonstration we will give a demo how this thread can execute in a different order and everything. So, this will give an idea about that the threads are running and invoking the sleep method, that means thread is going to the sleep there. So, basically here the thread that we have created here, we are sending a method to control or just change its state from maybe running to waiting state like this one, or blocking state, whatever it is. So, this way the sleep method, like this sleep method we can use many other methods as we have discussed in previous slides, namely resume, suspend, all these things, stop, all these things also we can call it here. So, appropriate code is to be planned for that to have it. Anyway, we will discuss all these things in our demo. So, that how the different methods can be called and then how their consequence is there. Now, so this is an example, again we will discuss the total execution of this statement, how this thread can execute it under the sleep condition. I want to skip here. So, for the theoretical, it is more aspects so far that how it basically run it in actual programming environment. So, this is the thread control we can say, and these are the basically the matter, the concept or the features. So, for the inter-process thread communication is concerned here, and this is another example of again inter-process communication of the threads as we see, and this is very interesting problem which usually occurs whenever multiple threads are in execution. The concept is called the data races. So, here is basically we create one class called the data race, which extend the thread class here, and here we declare one method run which use one static integer variable x there. Now, this method is basically used interchangingly for integer I equals to 0, I less than, these are the basically so many times this will loop, and for each iteration x equal to x plus 1 and x equal to x minus 1, as if this loop is executed. So, for every iteration x will be initially if x is 0. So, it is 1 then 0, 1 and 0, but interestingly if you run the thread this data race thread, and you see it should in this according to this one single thread it will always give the 0 as a value of x, but here the thing is that because of this intermittent execution and then what is called the data races are there. So, if we run this threads for this many loops, and you will see it always not give 0, it sometimes give 1, sometimes give 0. This is because the different thread whenever it in execution and it is a static variable. So, it print the different situation whatever the values are there in this intermittent execution. So, this is the idea about, and it basically called the data race example in the Java programming concept. So, this basically says that how the different threads are in execution, that you can check it using this kind of illustration. Now, so these are the different way the thread can be scheduled or thread can be communicated, inter-process communication we can say. And now, next is that a thread can be synchronized also. So, there are thread synchronization, and before this thread synchronization there is also one concept is called the setting the priority. Our next example is basically how the set priority of a threads can be established, so that the scheduler can schedule the execution of the thread according to their priority. Now, so far the priority of a thread is concerned, there are 3 different priority that can be there in the thread: mean priority, non-priority, and then max priority. So, they have their global value called 1, 5 and 10. So, we can set the priority of a thread by calling this method set priority, which is defined there in class thread. So, if this is the thread, and then we can call this method set priority and passing the number 1, 5 or 10, then it will set the priority according mean priority, non-priority or max priority. Otherwise, you can write this one mean priority is a global variable declared in the thread class itself. So, we can use it also. So, a thread can be assigned its priority, and once it is assigned, then the thread can be served using some CPU scheduling policy, for example, FCFS, fast come fast serve policy, look like this one. So, there are the way the thread can be there. Now, let us have a example, so that how this thread can be priority can be assigned, and accordingly the thread execution can be controlled. So, here is an example for this. So, here class A we create a thread, and then run method we defined here. Run method has a loop, and this is the loop control variable I equals to 1 to 4. So, loop will roll for 4 times, and each time the loop is rolled, it will print the value of I here, that means loop variables. So, this is the thread A, and similarly this is the class A, basically one thread that we have created. Now, let us have some more thread, because multiple thread execution is more interesting. So, here is the another example, and here is a class B, another thread that we have created. This also similar to the class A thread, but it just printing the variable, the loop variable of its own. And so, this is the class B, and similarly we can define another class, say class C, say another thread, and this is the class C thread, as we see class C thread, and then this also another run method, it will print the k. Now, we can see we have created just for playing only 3 threads by means of 3 classes, class A, class B and class C. They are the from thread class, their run method is created. Now, once these threads are created, now it is our turn that how this main class can be composed, so that all these 3 threads can be executed. So, here is the main method, as you see here, this is the main methods, and here we see we have created 3 threads, namely thread A, thread B and thread C of the class A, B and C that we have discussed. Now, once the thread is created, here we see we assigned the priority of the 3 threads, like thread C set priority, thread max priority, and then thread B set priority, thread A get priority plus 1. What is the priority? That the thread A priority is there, that by 1. So, this is the thread priority sets, and similarly thread B thread A priority also thread mean priority. So, these are the different way the priority can be set for some okay, different purpose we have setting this one. So, thread priority can be set this way. Once the priority is set, we just simply start the execution of this thread, and as you see, this is basically start, start and start. Now, as you see, whenever the threads are started, it is not started in this way. So, this is the first A will start, B will start, C will start, is not that. If you see the print statement, and then in our demonstration we will see how this program gives the print output, then you will see that here out of these which has the first highest priority. For example, here thread C has the highest priority, it will be executed first. Then we see the thread B is the next priority, because thread A the lowest priority. So, thread B will be executed and then thread A, and then the loop will be in a intermingled way, depending on the priority the different execution will take place. So, this way the thread priority can be set, and then it basically used by the scheduler to schedule the thread in its own way. Now, here is another example, the join method we have discussed. As I told you, it is also considered the so, if suppose one thread cannot begins if the other threads are not finished its execution. So, in that case the other threads which should be waited for to begin another threads, that can be controlled using join method here. And this is a very simple example. As we see, suppose T1 and T2 are the threads are created, then we create T1 is a thread and T2 is another thread by means of thread class somehow created there. And we create by some methods or Runnable interface, that is means. Okay, so, we have to implement the two run method by implementing Runnable interface that can be passed. So, the T1 and T2 the two thread object can be created, and then they can be started its execution by calling T1 start. So, what the thing is that these two thread will start its execution because of this, and then here try catch there is a T1 join T2 join. So, there is a T1 thread T2 thread, and then here T1 join T2 join. So, it will wait till all the threads are finished. So, then this one, then only it will come to this one, then it will execute the final statement. So, join is basically the idea is that if there are many threads are there, if we the join, so here the thread point execution will wait until all threads are finished its execution come here, then the next task will takes place there. So, this is the concept of join, is basically communicating the controlling the interprocess threads actually. Now, our last topics regarding this multithreading is basically synchronization of threads. Now, the synchronization of threads means that if two or more threads enter into same process, then it may leads to lot of abnormality. So, what we can do is that if we use the synchronizations, that automatically the Java runtime manager will control their execution, so that no two thread should not access the same data or same section together. That is called the critical section actually. Those are the students from computer science, they probably know that critical section or semaphore implementation. So, it is basically synchronizations. It is very simple. The methods which we want to synchronize, just use the synchronize keyword before them, and then synchronization automatically take care. It is so easy so far the implementation is concerned. Now, here let us have a very simple example that how the synchronization is there. Now, in banking transaction, say suppose one account where from the two, one from the ATM and one from the bank terminal want to access the same account sometimes. In one account, one transaction one wants to use withdraw and another is to deposit. Now, if they are not synchronized properly, then in fact it can lead to the different result. For example, say suppose in the account balance is 1000 and then once the deposit is 500 and withdraw is 300. If it is not successful, then what's the outcome will be that either it is so it is basically the correct output should be 1200 because 500 deposits and 300 withdraw, but if it is not successful, then you may get that output as either 1500 or 700 because of the abnormality the situation is there. This means that both the transaction deposit and withdraw should not take place simultaneously. Once if it is not finished, then others should not be executed like this one. So, this is the one example that to increase this one. Here basically one class account, that is a normal class which has some members and methods are there, basically balance, account number and display balance and whatever it is there. It is a very simple methods are there, and in this account we define two methods, deposit and withdraw, and the deposit is basically depositing the money. So, balance whatever it is there amount, it will be adjusted, and withdraw means it will just this one. Now, here we can see we use the keyword synchronized here, this one. This means that if the two methods are called for this class object account, then they are basically already called in a synchronized manner. So, it is right. So, this class is very simple to understand, and then only the thing that you should use the synchronized keyword here. Now, so this is the idea about, and here is basically the class transaction. We can say the transaction is basically implementation using threading example. Here we can see we implement transaction deposit. There are two methods, two transaction deposit class. One is related deposit, and it basically implements runnable. So, the run method as we declared here, this is basically the constructor of this class, and then run method is basically right account x dot deposit. Basically, this run method call this deposit method. So, this is the transaction deposit. Similarly, the transaction withdraw also another method, as we have declared here transaction withdraw. It is the same, the runnable interface, and this is the constructor for this, and here is the run method as C is basically called the withdraw method of this object account y. Now, so the two methods withdraw and deposit being synchronized, they are basically operated for the two operations. Now, here is the methods, the main method as you see. So, main method, this is the main method as you see. The transaction is the name of the class, and the main method it is here. It is basically for the account class we create an object ABC, and then that balance is 1000, and then we call this thread T1 transaction deposit, transaction withdraw. These are the two threads are executed in parallel, T1 and T2 are the two threads. That means, here we want to say imply that two executions are invoked at the same time, and then if there is no, you can run this program with removing synchronized, what will happen, and if you run this program with synchronized, what will happen. You can see readily the difference, but difference may not be always, because the data race example that we have discussed, because of these things it may leads to abnormal results, because if it is not there, but if you synchronize, it always give the correct result all the time. So, this is the idea about the synchronized, and then again in the stack implementation the same synchronized also we can use it anyway. So, that stack is basically the implementation in data structure that is there. So, I just want to avoid this discussion here. We will discuss these things when we will discuss about the in our demonstration. We will have more example and then more execution, so that we can run it. And so, this is the synchronization that we can have it, and using the synchronized word that we can control and then process the thread execution there. So, anyway, so this is about the multi-threading. The concept is very vast and many more things are to be discussed in details. Anyway, so although we have used the two modules, many more things should be discussed, while we will have a quick complete demonstration on the different aspects of multi-threading programming. So, this is about the multi-threading, and after the multi-threading the next thing is very important about that how the input and output to a program can be handled, because Java is for internet programming, and then input and output from the many sources. So, how Java can manage the different sources of inputs and then so output also we will discuss in our next discussion. Thank you.